Hello, student. Welcome to this chapter of arithmetic progression. In this session, I am going to explain the sum of first n terms of an arithmetic progression. So here first we will determine an expression for the sum of first n terms of an arithmetic progression. So we need a formula to calculate the sum of the first given terms of an arithmetic progression. So for that, we have to do this derivation. So let the terms of an AP are given by A, comma A plus D, comma A plus 2D dash dash dash. As you know, these are the terms of an arithmetic progression. So in this, you know that this A is referred as the first term of an arithmetic progression, and this D is the common difference of the any two consecutive terms. The nth term of this arithmetic progression is given by A plus of n minus 1 into D. So that means we can write an expression for this nth term like this. It is given by A plus n minus 1 into D. Next, let S denote the sum of the first n terms of the arithmetic progression. So we can write this as S is equal to A plus D plus A plus 2D dash 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 nth term A plus n minus 1 into D. Because this S represents the sum, that means we have to sum the all terms of the arithmetic progression. These are the terms. So we have to sum them. So it becomes A plus D plus A plus 2D dash 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 like that. Then we rewrite the equation 2 in reverse order. Just you rewrite the equation 2 in reverse order. So this is the equation 2. So S is equal to, so this is the last term that is written first here. So it is A plus n minus 1 into D plus. So this is the last but one term that can be written here. So that I have written here. So it is the term behind this which is present here. So that is A plus n minus 2 into D is the next term. Plus dash dash dash. So these terms comes, the starting terms. Here they are A plus 2D plus A plus D and plus A like this. So this is the equation 3. Adding the equations 2 and 3 term wise, this is very important. This is a term wise addition. So we get S plus S on LHS side, S and S are there. So S plus S gives the 2S. And this term and this term, their sum gives 2A plus n minus 1 into D. Because this A is added to this A. So it becomes 2A. So this becomes 2A plus n minus 1 into D. And next, addition is A plus n minus 2 into D plus A plus D. So A plus A again gives 2D plus D plus n minus 2 into D. So that gives n minus 1 into D. So in this way, we can continue the term by term additions up to the nth terms. What we are getting is that the same term is repeated. So this term is repeated. 2A plus n minus 1 into D is repeated when you add the terms of equation 2 and 3. So this goes up to n terms. So that is why there are n terms in this sum. So that is why we are multiplying this common term 2A plus n minus 1 into D by n because there are n terms. So 2S is equal to n into 2a plus n minus 1 into d. So this n we multiplied because there are n terms. Or s is equal to, it is n by 2 into, because this 2 is coming to the RHS, it comes to the denominator. So it becomes n by 2 into the bracket 2a plus n minus 1 into d. So we got the equation 4. And this equation 4 is generally referred or used to determine the sum of first n given terms. And this above equation is used to determine the sum of the first n terms of the arithmetic progression. And equation 4 can also be written in this way as s is equal to n by 2 into the bracket. This 2a will split like this, a plus a. So a plus a into plus these terms are there, n minus 1 into d is there. And this a plus n minus 1 into d is nothing but the nth term of a given arithmetic progression. So we will write this a plus n minus 1 into d as a an. So therefore, we are getting here as s is equal to n by 2 into a plus an. So equation 4 can also be written in this way. And suppose if an is the last term of the arithmetic progression, then you denote that an as L. Then equation 5 becomes like this, s is equal to n by 2 into the bracket a plus L. That means instead of this an, we are writing L to denote that it is the last term of the arithmetic progression. So in this way, we derived an expression for the sum of the first few terms or n terms of an arithmetic progression. Next, we will see some examples how the problems are given and how they are solved. So example 1, find the sum of the first 22 terms of the AP. AP is like this, 8, comma 3, comma minus 2, comma dash dash dash. And here, the first term is 8. This is the first term. And common difference is 3 minus 8 is equal to minus 5. So then go to this equation, which is right now derived. So it is given by s is equal to n by 2 into 2a plus n minus 1 into d. And put the values. The value of n is 22. So it is 22 divided by 2 into 2a. A is 8 plus n is 22. So it is 22 minus 1 into d is minus 5. They are all substituted. 22 by 11. 22 by 2 gives 11. 2 into 8 is 16. 22 minus 1 is 21 into minus 5. So you simplify. 21 into minus 5 is 105. It is minus 105. Minus 105 plus 16 gives a minus 89. So this minus 89 is multiplied to this 11. So this 11 into minus 89 gives a minus 979. So we got this minus 979 as the sum of first 22 terms of the given arithmetic progression. The problem is solved. Go to the next problem. Here, if the sum of the first 14 terms of an arithmetic progression is 1050 and its first term is 10, find the 20th term. So this is the problem. So there are the sum of the first 14 terms is given, that is 1050, and total number of terms are 14 because he's telling 14 terms are there. So n is equal to 14, and the first term a, small a, is 10, and he has not given the common difference d, and we have also determined the 20th term. So by making use of this sum equation, Sn is equal to n by 2 into 2a plus n minus 1 into d. Sn is 1050 and n is 14 divided by 2. 2 into A is 10, substitute, and n is 14, 14 minus 1, and D we don't know. So all the values are substituted. So simplify this one. It is 1050 is keep as it is. 14 by 2 is there, that becomes 7, and 2 into 10 is 20, you write, plus that 14 minus 1 is 13 into D. Next, multiply this 7 to this bracket. 7 into 20 is 140, and 7 into 13 is 91, so it is 91D. Or 91D is equal to, take this term to other side, so it becomes 1050 minus 140. This is equal to 910. Or D is equal to, that means 91D is equal to 910, or D is equal to 910 divided by 91. So this 91 becomes to the denominator. So 910 divided by 91 is 10, because it is 10 times. So therefore we got the value of D, it is 10. So once the D is obtained, you calculate the 20th term. So therefore, the 20th term is given by A20 is equal to A plus n minus 1 into D. Use this equation. A is 10 plus n is 20. So 20 minus 1 into D. D is 10. So this is equal to 10 plus 20 minus 1 is 19 into this 10. This is equal to 10 into 10 plus 19 into 10 is 190. So 190 plus 10 is 200. So that means the 20th term is equal to 200. So in this way, the problem is solved. Go to the example 3. So example 3 is like this. Find the sum of the first two problems are there. The first problem, the first 1000 positive integers, and problem 2, the first n positive integers. So for the first, we take the first one. Let s is equal to 1 plus 2 plus 3 dash 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 1000. So here in this sum, a is the first, a is equal to 1 is the first term. Last term is 1000 and n is equal to 1000, because there are 1000 terms are there. N becomes is equal to 1000. So then using the relation, S is equal to n by 2 into A plus L. Put the values. N is 1000 divided by 2 and A is 1. So 1 plus L. L is 1000. It is 1000. So 1000 divided by 2 is 500. And into this 1000 plus 1 is 1001. And 1001 into 500 gives 500 like this. That means it is 5 lakh 500 will get as a sum. So the first problem is solved. Next, we want the sum of n integers. So let Sn is equal to 1 plus 2 plus 3 plus dash 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 n. And here again A is equal to 1. The last term we have to take L as a n, and there are n terms. So using the earlier equation, Sn is equal to n by 2 into A plus L. And here this L becomes n. So because n terms are there, so this is becomes n by 2 into A. A is 1 and L is n. So it becomes 1 plus n, or Sn is equal to n by 2 into n plus 1. So this formula we should use when we are going to determine the sum of first positive integers. So the second problem is also solved. Go to the fourth example. In the fourth example, find the sum of first 24 terms of the list of numbers whose nth term is given by an is equal to 3 plus 2n. So here the general term is given, which is the nth term, which is given by an is equal to 3 plus 2n. So here we have to put this n is equal to 1, comma 2, comma 3 times dash 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 to get the various terms of this arithmetic progression. And suppose if you are putting n is equal to 1, it becomes a1. a1 is equal to 3 plus 2n, 2 into 1. So 2 into 1 is 2, 2 plus 3 is 5. So this is the first term. Next put n is equal to 2. It becomes 3 plus 2 into 2. 2 into 2 is 4. 4 plus 3 is 7. Like this. Put n is equal to 3. a3. 2 into 3 is 6. 6 plus 3 is 9. Put n is equal to 4. The term is a4. 3 plus 2 into 4. 2 into n. 2 into 4 is 8. 8 plus 3 is 11. So in this way, we got the different the terms. So first few terms of this arithmetic progression. So the terms of the arithmetic progressions are like this: is 5, comma 7, comma 9, comma 11. So that you write here. Then we have to check that whether these are making an arithmetic progression or not. For that, they should have a common D. So check for the common difference. So common difference, second term minus first term, and next term minus earlier term. So 7 minus 5 is equal to 9 minus 7 is equal to 11 minus 9 is equal to 2. In all these cases, the difference is 2. So they have the common difference as a 2. So therefore D is equal to 2. And first term is A is equal to 5 and N is equal to 24. Next, the sum of first 24 terms we have to determine. Now it is possible because D, we have determined the D. So the sum of first 24 terms is equal to n by 2 into 2a plus n minus 1 into D. So n is equal to 24 by 2 into 2a. A is 5, put its value, plus n is 24, 24 minus 1 into D. D is 2. Simplify, 24 by 2 is 12 into the bracket. 2 into 5 is 10 plus 24 minus 1 is 23 into 2. This is equal to 12 into 23 into 2 is 46. 46 plus 10 is 56. So it is 12 into 56. 12 into 56 is 672. So that means the sum of the first 24 terms is 672. So the problem is solved. So now important, we are going for the exercise 1.3 and we are solving all the problems present in this one exercise 1.3 without leaving anyone. So next here find in the main question, find the sum of the following APs. So 4 APs are given. This is first AP, second AP, third AP, fourth AP. We'll solve one by one. So take the first AP. The first AP is like this. When you say that it is AP, we need not check for the whether means whether all the terms will have the common difference or not. If it is not mentioned that it is AP, then we have to check. So here they have told that AP means they are all arithmetic progressions. Just to get the value of common difference by taking any two consecutive values or terms. So here the first term is A is equal to 2. So this is the first term, and common difference is 7 minus 2 is equal to 5. That means you need not check whether 12 minus 5, 12 minus 7 is 5 or not, because they are told that AP. So taking the first term is enough to calculate this common difference. And n is equal to 10. 10 terms are there. Then the sum of the 10 terms is given by S10 is equal to, it is n by 2 into 2a plus n minus 1 into D. N is 10, so 10 by 2 into the bracket. 2 into A is 2. plus n is 10, 10 minus 1 into 5. So 10 by 5 is 10 by 2 is 5 into the bracket 2 into 2 is 4 plus this is 9, 10 minus 1 is 9, so it is 9 into 5. So this is equal to 5 into 4 plus 9 into 5 is 45. 45 plus 4 is 49. So 49 into 5 is a 245. So we got the sum as a 245. Next problem. The terms of the given arithmetic progressions are like this: minus 37, minus 33, minus 20 dash dash dash. 12 terms are there. So the first term is minus 37, and common difference you determine. So it is minus 37 minus of minus 37. So this is minus 33 plus 37, because this minus into minus becomes a plus. So it is minus 33 plus 37. So this gives a 4. And n is equal to 12 because there are 12 terms are there. Then I get the sum. So sum is like this. It is s 12 is equal to n by 2 into 2a plus n minus 1 into d. N is 12, so put its value, it is 12 by 2 into 2a. A is minus 37, so 2 into minus 37 plus n is 12, so 12 minus 1 is 11 into 4. This is simplify. This is 12 by 2 is 6. 6 into the bracket 2 into minus 37. 37 into 2 is 74. So this becomes minus 74 plus 11 into 4 is 44. And this minus 74 plus 44 gives minus 30. So this minus 30 is multiplied to this 6, which is carried here. So now it is 6 into minus 30. So this is equal to minus 180. So that means the sum of these first 12 terms comes out as a minus 180. The problem is solved. Go to the next problem. The terms are like this: 0.6, 1.7, 2.8, dash 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 up to 100 terms. The first term is 0.6, and the common difference is 1.7 minus 0.6, it gives 1.1, and n is equal to 100. So put into this sum formula. Yes, 100 is equal to 100 divided by 2 into a is 0.6 plus 100 n minus 1, that means 100 minus 1 into d is a 1.1. So this is equal to 100 by 2 is 50 into 2 into 0.6 is 1.2 plus 100 and 100 minus 1 is 99 into 1.1. So this is equal to 50 into 1.2 plus of 99 into 1.1 is 108.9. So this is equal to 50 into this 1.2 plus 108.9 gives 110.1. So this 110.1 into 50 gives 5505 as the sum. So if you want to avoid this decimal point, which is little bit problematic or leads to confusion, you can write the same problem in different way. So from here, so it is 50. So 1.2 you have to write as a 12 by 10, because 1.2 means you can write this as a 12 by 10 plus 99 into 1.1 you write as a 11 by 10. Now this is 50 right as it is, 12 by 10 as right as it is, plus now it is 99 into 11 is 1089 divided by 10. And now 50 you write as it is, take the LCM. Here also 10 is there, here also 10 is there, 10 becomes the LCM. So it is 12 plus 1089 and divided by 10. So this 10 you can cancel with this 50, because 10 ones are 10 fives are, so it becomes 5. Into the bracket, this 12 plus 1089 is 1101 And this 1101 into 5 gives a 5505. So in this way, you can avoid the decimal point and you can solve it, and the answer will be the same in both of the cases. So this is the last fourth problem of the main category. So the terms are like this: 1 by 15, 1 by 12, 1 by 10, dash, 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 11 terms are there. And here the first term is 1 by 15, and take the common difference. It is 1 by 12 minus 1 by 15, because this is the second term, this is the first term. So here the LCM becomes 60. So 12 5 is 60, so it is 5 minus 5, 15 4 is 60, so it is 4 here. So it is 5 minus 4 divided by 60. 5 minus 4 is 1. So it is 1 by 60. And here n is equal to 11, because 11 terms are there. Then go to the sum equation. It is S11 is equal to 11 by 2 into A is 1 by 15 plus n minus 1. So 11 minus 1 into D is 1 by 60. So this is equal to 11 by 2 into, you write 2 into 1 by 15 as 2 by 15, and plus 11 minus 1 is 10. So 10 into 1 by 60. And now you can cancel here. It 10 ones are 10 6 are, so it becomes 1 by 6. So 11 by 2 you write as it is, and you write 2 by 15 as it is, and this becomes 1 by 6 after cancellation. And now for this 15 and 6, 30 is the LCM. So this 11 by 2 you write as it is. So for 30, 15 2s are 30, so 2 into 2 is 4, plus 6 5s are 30, 5 into 1 is 5. LCM is taken and simplified, and write 11 by 2 as it is, and this 4 plus 5 is 9, so it becomes 9 by 30. And now you can cancel some things. So it is 11 into 9 is 99, 2 into 30 is 60, so it is 99 divided by 60, and it is cancelable by 3. So it is 3 2s are 6 and 0. And 3 3s are 3 3s are, you cancelled with 3, and so it becomes 33 divided by 20. So that means the sum of the first 11 terms gives 33 by 20 as the answer. Go to the second main. Here also 3 problems are there in the second main, and you take up the first problem. The first problem, the terms are like this. Here also we have to find the sum of these. So here 7 plus 10, 1 by 2 plus 14 plus dash 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 84 is there. A is equal to 7 is the first term, and common difference you take, you calculate 10 1 by 2 minus 7. So this is the mixed fraction. Make is in the simple fraction. So 2 tens are 20, 20 plus 1 is 21. So it becomes 21 by 2 after conversion. So it is 21 by 2 minus 7. Take the LCM, 2 is the LCM. So it is 21 minus 14, because 1 2s are 2 into 7 is 14. So 21 minus 14 divided by 2. So this gives 7 by 2. So we got the value of D as a 7 by 2. So next we have to determine the number of terms given present in the given sum or given arithmetic progression. And here is given that AN is equal to 84, means one term is having the value 84. So using this, we can determine the n value. So using the nth term equation, AN is equal to n plus n minus 1 into D. AN is 84 plus it is A, sorry, not N, it is A plus N minus 1 into D. A is equal to 7 plus N minus 1 into D is 7 by 2. So, or we have to simplify for this N minus 1. So, we take this 7 this side. it becomes n minus 1 is equal to 84 minus 7 into 7 by 2. Into 7 by 2 is there. When it goes to the RHS, it becomes 2 by 7. It gets ulta. And 84 minus 7 is 77 into 2 by 7. We have to write. So here 7 ones are 7, 11s are get cancelled. So 11 into 2 is 22. That means n minus 1 is equal to 22 or n is equal to 23 because it is 22 plus 1, so it gives 23. So in this way, we got an expression for n or the value of n we obtained. Next, you go for the sum. So S84 is equal to n by 2 into 2a plus n minus 1 into d. N is 23 divided by 2. 2 into a is 7 plus n minus 1 is 22. You can write directly because n minus 1 is equal to 22 into d is 7 by 2. You cancel here 2 ones are 2 ones are 2 ones are, so 22 get cancelled. So write the remaining terms. 23 divided by 2 into 7 is 14 plus 11 into 7 is 77 like this. So this is equal to 23 divided by 2 into 14 plus 77 is 91. And now 91 into 23 is 2093 and divided by 2, or we can write this in mixed fraction form as 1046 into 1 by 2, because 2 into 1046 is 2092. This plus 1 we have to make, so that gives 2093. So this converted into a mixed fraction. So this is the answer. Next problem. The terms are like this. A is equal to 34 is the first term. Common difference is like this. 32 minus 34 is minus 2, and there are 10 terms are there. Means he has given up to 10th term. So between this 34 and 10, how many terms are there? We have to determine. So you make use of the nth term formula again. An is equal to a plus n minus 1 into d. An is 10. A is 34 plus n minus 1 into d is minus 2. Take this 34 to either side. And this multiply this minus 2 into n minus 1. This gives minus 2n plus 2. Minus 1 into minus 2 is plus 2. You simplify for 2, it is 2n to LHS side. Take all terms to RHS. It becomes, it is 34 and it becomes minus 10. This is plus 2. So this gives 26. That means 2n is equal to 26 or n is equal to 26 divided by 2. This is 13. So we obtain the value of n. Next, we go for the sum. The sum is s is equal to n by 2 into 2a plus n minus 1 into d. Put all the values. N is 13 and 2a is 34 plus n minus 1 is 12 into minus 2. So this is equal to 13 by 2. This is 34 into 2 is 68 minus this one 12 into 2 is 24. So this gives 44. 68 minus 24 gives 44. So this is 13 by 2. 13 by 2 into 44. Here you can cancel 2 ones are 2 twos are 2 twos are. So it becomes 13 into 22. 13 into 22 is 286. So the sum is 286. Go to the last problem. The terms are like this: minus 5 plus minus 8 plus minus 11 dash 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 up to minus 230. First term is minus 5. Determine the common difference d is minus 8 minus of minus 5. So minus 8 plus 5 is minus 3. So d is equal to minus 3. Then nth term is given, that is minus 230. Using this, we have to determine the n value. So it is minus 230 is equal to a is minus 5 plus n minus 1 into d is minus 3. And you take this minus 5 to this side, it becomes minus 230 plus 5 is equal to n minus 1 into minus 3. And minus 230 plus 5 is minus 225. And I have taken this minus 3 to LHS, it goes to denominator. So it is minus 3. So minus minus get cancelled. So 3 ones are 375, it goes. That means n minus 1 is equal to 75 or n is equal to 76. So we obtained the value of n. Now you go to the sum as like this. So S is equal to n by 2 into 2a plus n minus 1 into d. N is 76, 76 divided by 2 into 2 into a is minus 5 plus n minus 1 is 75 into d is minus 3. So this is equal to 76 divided by 2 and 2 into minus 5 is minus 10 and this minus into this plus gives minus and 75 into 3 gives a 225. So this 225 minus 10 is minus 235 and 76 divided by 2 is 38. You multiply these two, we will get sum as minus 8930 as the sum. So the problem is solved. So here the problems are little bit tricky, and what is given and what is to be given, you have to understand very carefully, then only you can do the sums. So next, I am going to continue this exercise 1.3 and we will solve all the problems. Thanks for listening.